So our objective for today is to be able to solve linear equations and verify the solutions. In order to do our solving, we should remind ourselves of the order of operations. So when we're working on our mathematics, we have our rules called your order of operations, and we look for the following items. The first thing we look for are any grouping symbols that are being used in our equations. They could be parentheses, brackets. Then we look for powers and exponents. Then we look for multiplication or division going from the left to right. And then finally we look for addition and subtraction from the left to right. So we're going to employ those order of operations to help us with the solving. So the order of operations were helping us simplify expressions before. And when we're solving an equation, we have to undo those order of operations according to the rules. So we're reversing them in order to solve for what's missing in the equation, the variable. So here, our first example, we have 3x plus 7 equals 10. So we're going to think about the order of operations. Normally, if we were going to evaluate this, we would do the multiplication first, then the addition. So again, since we're solving it, because we don't know the value for x that makes this true, we're going to do the reverse of the operations. So the last thing we're going to do is the addition. We're going to start here and undo that. Well, what undoes addition? That would be subtraction. So we would subtract 7 from each side of the equation. That would leave us with 3x equals 3. Then we had the multiplication, and we're going to undo that. So to undo multiplication, that's division. So we divide each side of the equation by 3. Therefore, x would equal 1. Now we always want to verify that this really is the correct value for x that makes this equation true. So we're going to substitute the value into the equation and make sure we get a valid statement. So we're going to substitute the 1 in for x, so 3 times 1 is 3. Then add the 7, 3 plus 7 is 10. That's a balanced equation, so this is the correct value of x that makes that equation true. Let's try another one. Here we have n divided by 2 plus 4 equals 10. So again, thinking of the order of operations, normally we take care of the division, then the addition to get to our result. So we're going to undo that. Well, the last thing we would do would be the addition, so we're going to undo that. To undo the addition, that would be subtraction. So we're going to subtract 4 from each side of the equation. Now we have n divided by 2 equals 6. So to undo the division, that's multiplication. So we're going to multiply each side of the equation by 2. So a quick reminder, when we're multiplying fractions, we multiply across numerators and denominators. So that would be 2n over 2 equals our 6 times 2, which is 12. Now remember, these will divide out and make a 1, so we have n alone, so n equals 12. Last thing we have to do is verify that this is the correct value for n to make that equation true. So we're going to substitute 12 in for n and see if it works. So let's think about this. Order of operations, take care of the division. 12 divided by 2, that's 6. 6 plus 4, that's 10. So we have the correct value for the variable to make the equation true. Here's another one. We have 2/3 x minus 1 equals 5. We want to find the value for x that makes this true. So again, thinking about what we've done in the other two problems, we're going to undo the order of operations. So here, looking at the subtraction, to undo that, we'd have addition. So we would add 1 to each side of the equation. So now we have 2/3 x equals 6. Well, a fraction is the same thing as division. It's really 2x divided by 3. So to undo the division of 3, we can multiply each side by 3. That means, again, reviewing your fractions, multiply across, we'd have 6x over 3 equals 18. And we can simplify this fraction because 3 is a factor of 6, so this would now be 2x equals 18. Again, here's multiplication. To undo the multiplication, we can divide each side by 2. So we'd have x equals 9. Another way that we could talk about this is you talked about the fractions before. We said, oh, wait a second, instead of undoing the division and the multiplication, we talked about how we could take care of both of those things at once, which means multiplying by the reciprocal. So if we see the 2/3, we could multiply by 3/2. Again, that would take care of the division of 3 and the multiplication of 2, undoing those. And we end up with the same thing. So we already have the 6x over 6 that would divide out and make our 1x. 19 divided by 2, divide out the factor of 2 to give you the 9. And again, still x is equal to 9. Regardless of the method that you choose, we still have to verify that 9 is the correct solution for our equation. So is that the right value of x to make it true? Well, let's check. If we substitute that in, again, thinking about multiplying your fractions, we multiply across. We'll have 18 over 3. Well, we know 18 divided by 3 is 6. 6 minus 1 is 5. So we have the correct value for x to make that equation true. One more here. We want to solve our equation. We've got 4a plus 3a equals 28. Well, we can see that we have some like terms here that we can combine together. So 7a equals 28. We can undo that multiplication by division of 7 on each side of our equation. So a equals 4. We just have to verify that's the right value for the variable. So let's check it. We're going to substitute 4 in for a in each part of our equation. We know 4 times 4 is 16, 3 times 4 is 12. 16 and 12 does in fact give us 28, so we have the right value for a for our equation. So that was a quick review of solving your equations and verifying their solutions.